All right, now that we have an idea of what an exponential function looks like, let's look at a more specific example. We're given a bunch of data here. What we're going to do is we're going to enter this into the calculator. But let me quickly explain something. This is going to be my L1, and it actually doesn't matter what you want to do here. These actually are the same thing. Okay, this is just rounded off this side. If you prefer to put the full number in, that's okay. But what we've done here is we've just said let's change this to 2 decimals and kind of simplify the numbers so we don't have to enter such large numbers in there. Okay, so instead of writing 2,436,297, we're saying this is 2.44 million. Okay, so we're going to use this as L2. But if this became a test question and you decided you didn't want to use this, you're going to get the same answers. Okay, we're just trying to make it simpler to enter. Okay, so let's start by putting this into L1 and L2. We're going to do one other thing, before we go further here. Rather than we go 1871, 1881, I'm going to go and use these numbers as to represent my years. Okay, now that's going to mean we're going to have to pay attention a little bit later. But the reason we're going to do it this way is if we used 1871 as our first x value, if we do the graph and we start here at 0, like 1871 is way over here already, and this whole graph will be empty. Okay, so what we're trying to do is just kind of clean up the graph a little bit. Okay, so let's enter. So we'll put in here 0, 1, and just keep putting all of these in up to 10. Okay, once I have those in, I'll go over here, and now I need to know what to put in here. So I'm going to go 2.44, 3.23, etc. Just put all of these in. Oh, made a mistake. So what did I do wrong? Oh, look at that. Okay, should be a 0. Okay. All right. There they're entered. Now what I'm going to do is I'll go here and, well, let's clear that. Let's go up to the plot, turn it on, and I'm going to go zoom 9 to see what the graph looks like. Okay. Now what I want to do is come up with the equation that represents these points. So I'm going to press Stat Calc, and I'm looking at that and it looks like it's going to be an exponential graph, which kind of makes sense because that's what we're doing in this unit. Okay, and so let's just press 0, exponential regression, and I'll go L1, comma, L2. So there is my equation. Okay, and so let's write that down here somewhere. Using graphing technology, create a graphical model and an algebraic exponential model for the graph. So let's take a look at what this says. This says y equals a times b to the power x. A is 2.668. Let's go to 2 decimal places. So a is 2.67, and then b is 1.24. So times 1.24 to the power of x. So that's my equation. Okay, so let's go here and we're going to put it into y equals. We'll paste it in there, so that's vars 5, and then the equation, enter. So it just pasted what we had there, and now if we graph, it should model our data. And it does. It looks pretty good. Very quickly, let's go to trace. Actually, we'll go to second trace because I want to find what the y-intercept is. So I'll press 1, And if I put x is 0, my y-intercept says 2.67. Okay, so let's go here and start. The y-intercept is 2.67, and the graph looks something like this. By the way, notice we're not going to go negative. This is our 0 entry, which was actually 1871. Okay, and we had all those dots there. And this is pretty good, 2.67. This is our A value. So it looks good. Just a quick comment on that though. When x is 0, our initial point is actually 2.44, not 2.67. Why are those different? Well, don't forget that when we're making our equation and we're putting that line on, we're doing what's sort of the best representation. It's not going to fit every point exactly. Okay, so this is not a concern. It's close enough for us to say, yeah, we'll take that. That looks like that's where we're going to start with our equation. Okay, so there's our graphical model. Here's our algebraic model. Now it says, assume the population growth continues at that rate. What will the population be in 2011? Okay, well, we go from 0 to 10. 10 is 1971. So here we have 1971. What we're supposed to do is keep going here until we get to 2011. And we're supposed to figure out what exactly will the population be here. Okay, how are we going to figure that out? Well, let's quickly remember that this is our 10th entry. Okay, and we should think about that a little bit. So if our 10th entry is 1971, our 11th entry would be 1981, our 12th entry would be 1991, 13th would be 2001, and the 14th entry would be 2011. So this is the one we're looking for. Okay, so let's go to our equation here. And what do we want to do? How do we find when x is 14? Well, we can use a calculator. We'll go here and we'll say, let's put x as 14 and press enter. Invalid. What's the problem? Let's press 2. It says 14's the problem. Why do you think 14's a problem? Well, does it make sense that 14's actually not on the graph that we see here? Okay, in fact, if I go to the window, alright, I'm going to press window. Can you see that the biggest x value we have there is 11? So I'm going to change that. I mean, I don't need to go to 20, I could just go to 15, but I'm just going to change it to 20. Okay, so now let's graph it. And now we should be able to say, I want to figure out when x is 14, what do we get? Well, we get y is 54.15. Now that's actually not on the graph, you can't see it. So we could go and change the y value. Right now it's at 24, we could change it all the way to 60. So now I can see where y equals 20. Sorry, y equals 4, or x equals 14. X equals 14. So now you can see it flashing there. It's 54.15. Okay, so in 2011, the exponential equation says y equals 51. What was it? 54.15. 54.15 million people. Okay, so that's how we do a question like that. I'm going to give you a few minutes to try the same type of question, but this one is a decay. Now the last one said growth. growth meant it's going up like that. Okay, a decay means we're having an equation like this. All right, and it says trial 1, trial 2, trial 3. Put this all into the same scatter plot. So we're going to call this L1, 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 and this is L2, L2, L2. Okay, so I'll give you a few minutes. I'd like you to pause this video and see if you can put this all in the calculator and answer these questions. Okay, so the first question it asks us to do is to construct a scatter plot to display the data. So once you've plugged everything into the spreadsheet and you press zoom 9, you get something that looks like this. Let's, just put a couple of points here because it looks something like this. And we're supposed to determine the equation. Okay, so the equation, we're going to go to Calc, and it's the exponential regression. So we press, let's just clear this out here so it's not confusing. Okay, so press 0, and I'm going to go L1 and L2. So there's our equation. Let's write it in here. Okay, y equals 78.68 and then 0.97 to the power x. Now notice 0.97, that's less than 0, or sorry, less than 1. That's why we have a decay, we have a graph going down. Okay, so let's plug that into y equals. We'll go y equals vars 5 equation. Enter. There it is. Now if I go back to graph, you've got a line that represents those dots pretty well. Okay, and if we quickly calculate the y-intercept, we have a y-intercept of 78.68. Okay, and so the graph looks something like this. Okay, so that's part A. Part A said construct a scatter plot. We did that. Determine the equation of the exponential regression. We did that. Now, part B says estimate the temperature of the water 15 minutes after the experiment began. All right, 15 minutes. Where is that? Well, the data we have is at 0, 5, 10, and then 20. So what we're looking for is what's going on at 15. So let's go to value again, and this time instead of putting 0, I'm going to say I want 15. Oops, I'm having some trouble with my calculator. I'll try that again. Okay, so y is 51. So at x equals 15, and that's minutes, y equals 51. And what is the unit for that? Well, that's temperature. So it's 51 degrees. Okay, that's B. Round your answer to the nearest degree. We did that. Estimate when the water temperature when the water reaches a temperature of 30 degrees. Okay, so we want to know when it's 30 degrees. Well, one way we can do that is just to trace. If I trace along this graph, okay, let's see where we are here. We're at x is 30, y is 34. Well, that's getting pretty close, but we need to go a little further. What the heck is my thing doing? Okay, I can keep moving along here using my right hand arrow, and I want to know when y gets to about 30. Okay, getting closer, getting closer. That's pretty close there. That says x is 33.28. I'll go one more. I'm not sure that's any better, so I'm going to say it's at about 33 minutes. Okay, so y is 30 degrees. At approximately 33 minutes. Okay. So that's that question. All right, and if we want to do a little bit of homework, we'll go right here. Okay, these next couple of pages. Okay, it just involves doing some more graphing.